So today my talk is ostensibly about UI patterns. But by show of hands, how many people have used something like jQuery UI, either with or without Ember before? All right, so pretty much everyone. All right, of those people, how many people just really use the date picker? All right, that's what I thought. I asked this question a lot, and it's pretty much exactly the same people. All right, so how many people wish Ember had a UI widget library? All right, good. I aim to disappoint. So UI patterns, but this talk is actually really about code reuse and what I think are appropriate levels of code reuse. We'll just be using UI patterns as kind of a lens to talk about this topic and how it applies to building applications. So to do that, I want to paint a picture of sort of where we've come in terms of understanding code reuse as an industry. So here's a quote from a book on engineering management. There was a time where when you hired a skinny-tied, chunky-glassed hipster to work on code, it wasn't just his skills. It was you were literally also buying hiring processes and code that he had previously written, and he would sort of take with him like some sort of wandering samurai who like has these skills, and they come along with him. This, by the way, after Creative Commons it, is from the Seattle archive. They want attribution, so there it is. So up until the 70s, people really didn't know if that represented good architectural rigor, right? Like there was a point where we didn't know whether reusing software was even possible. And now here we are like 50, 60 years later at a framework or a conference about a framework. Our forebears were living in a world where there was the potential that like code reuse just wasn't a thing. Like you could never reuse code. Problems were so specific, you just had to handwrite everything basically. So that was a topic that they needed to know more about, and they started studying it. And the way they studied it, or I guess the question should be like, how is software reused? And academic engineering types basically center that discussion on a dichotomy of reuse in the large versus reuse in the small. So in the small reuse is basically libraries, things that you call from your code when you need to build larger applications. So if you think of an application as a layered series of concerns like this between a human interacting with them and some data, libraries essentially live at a single horizontal level and provide code. And the gray parts in between are the code you write. Sorry. So to borrow an example of this from server application development using specifically Ruby on Rails, you might have a library like Formtastic that basically is about generating forms, right? It lives pretty much in the view layer and doesn't cross concerns down to, it doesn't affect how your schema looks, right? Or conversely, like a pagination library really lives at the data fetching layer and will return, arrays of records in a particular way. Doesn't do a lot with flow control, right? It's not saying like if there are 30 records, do this. If there are 50 records, do that. That's up to you to code. So that's more typical. So here's an example of, these are underscore functions, right? Reuse in the small tends to be very loosely coupled, and each library remains mostly ignorant of what other libraries are doing. The downside to this, at least in my opinion, is your application tends to be heavily focused on gluing these components together. It's like a form of technical bricolage. And there's a cost in development time to doing this, especially if you end up solving similar problems over and over again. And that cost isn't just technical, it's also social. So imagine you're this guy, you're bringing domain knowledge of how to assemble applications of a certain type, and you encounter the other guy who also has been doing that, and your opinions differ wildly because you're not reusing code. What happens? The typical case is these people get into a fight and probably can't be on the same team anymore, and that's kind of a waste. So tension between programmers, especially good programmers, is a real business problem. In the large reuse, often called component architecture, encapsulates a single domain across many concerns. So if you think back to this layered stack of an application, think of it more like this for components. Instead of separations by concern, we have separations by domain that cut across all concerns, and the glue code combines these together. So you imagine you're building a larger application. You may have a shopping cart, a drop-in shopping cart, right? A drop-in blog system. And these domains typically do not touch each other, and the component covers everything from data persistence to flow control up to presentation, right? And depending on your development background, this probably either sounds totally reasonable or utterly crazy. So if you've developed mostly web pages, this is pretty much what you've done, right? Like WordPress or Drupal, you're going to go out, do a base install, find a plugin that mostly matches your needs, install it, configure it, and call it a day. If you've done application development and you crack open like your node modules folder or your gem file, you're not going to see a lot of libraries that cut across concerns. They're mostly going to be ones that live at a particular layer and provide functionality at that layer. So why? So components are written to not fully expose everything about them, right? They expose only a small subset of their behavior through configuration. So typical option settings. So if you think of this slide, I didn't have internet access, it was supposed to be the full set of configurable options for tiny MCE, because there's like 600 things you can configure. Some of them are mutually exclusive, right? Like there are some that as a human you know, like I can't set these two things to true. It won't make any sense. So essentially that, as a developer making a component, you're really hoping that you, through option configuration, can cover a large enough number of use cases to make the component useful. And as a consumer of that, if it doesn't match your needs, you basically are going to have to dive in and customize it, right? So who's done that before? Who's taken external dependencies and said, forget it, this doesn't do exactly what I need to start editing it. All right, so it's a nightmare, right? So how does this fare? Not too well. And the real question we should be asking is like, where does that break down? Obviously, if you need to write 100%, well, that's crazy. You've just rewritten an entire component. That's stupid. But I mean, how many people would think that would be like 80% reuse would be acceptable? So if you only needed to rewrite 20%, you'd be fine. 30, 40. The number is actually surprisingly small. 15 to 20% is the sort of going research about this. So that means if you need to customize around a fifth of the functionality of a component, it is cheaper to write it from scratch. So just in case you're bad at math, that is what 15% looks like. So it's tempting. Like I know I've been there. It is tempting, but largely unworkable to try to bend imperfect components into perfect ones. So here's another quote. I forgot to put the attribution on it. So if this quote is true, and we generally reject reuse in large for server application development, why does component style development show up so frequently when we're doing? Sure.
It's the thing's just cutting it.
Okay, fair enough. Where was I?
Sorry.
That's fine. Whoa. Hello.
Cool.
Okay.
Sorry about that.
Oh, no, that's fine. So why does component style reuse exist so predominantly in the browser? My thesis is two things. One, the lack of sensible structure generally, because we're not dividing behavior into sensible concerns, means that reuse overall in browser applications is fairly low, and this has just been the approach that people have done. So the other reason is statefulness. I'd say optimistically probably triples complexity. Realistically, it's probably closer to an order of magnitude. And there's a tendency to balk at the effort required to build a stateful application, either from clients or management or the developer themselves, where they look at the amount of work required in what they thought was a simple case, but because you're working in a stateful environment, it turns out to be way more complicated than you thought. And you just reach instinctively for anything that's going to make your work easier. So if I asked you, which do you think Ember is? Who would say reuse in the large? And reuse in the small? Most of you are right, because I would say probably neither. Boom, mind blown. Because in fact, this is what frameworks are about, right? It's a level of reuse that is more complex than like subroutine or object, but less complex than the component. You get simple primitives acting in concert. There's a public API with known behaviors. Granted, it might change every 4 days, but that's a thing that happens until you reach version 1.0 and grow up. You're usually limiting scope to a particular kind of behavior, data modeling, serialization, flow control, aggregation, and then primitives at one layer know how to interact with primitives in the layers around them. So in general, like for building UI components, how does Ember do if we had to give it a grade? How does it do at the task of putting together highly interactive units today, and where can we go? So I'm going to really quickly, because I'm trying to keep us up on time, which is why I'm talking so fast, go through some typical widgets and talk about how we break them down using existing Ember components and sort of where things fall apart. So first, a popover. Seems pretty simple until you've ever coded one. At a high level, you think, okay, it's not a big deal, right? Like you click an element, and then another element shows up in a proximal position, done deal. So a person clicks there, this shows up, they click the back button, you accept whatever changes they had, and you remove this element from the DOM or maybe hide it. So it seems pretty simple. But then you start to handle the edge cases. What happens if people click up at the navigation on the top? Do I retain the data that's been changed in that widget, or do I reject it? The answer isn't always the same, right? It depends on your application needs. What if they click another widget, or click where another widget is that would itself have a popover? Do you just hide this popover, or do you toggle to the other popover? What do you do with the data? What if they click someplace totally crazy? You need to, do you keep the data? Do you reject the data? Do you close it? Do you not allow them to do that? So there's a ton of questions that need to be answered, and you can see why you want this to be a reusable component. What if the height of the element in the popover changes, and you want to retain that horizontal centering? That's really hard to do because of the way we're probably positioning this in the browser. Things don't sort of grow from the middle up and down. They go from the top down. What if asynchronous data loading means a new list shows up in there? How do you make sure that the popover stays synchronized in the visual landscape with the thing that it was connected to? So pretty quickly you can see okay, statefulness in a browser, not as easy as you thought. So if we were going to take this UI component and break it down into a list of requirements, it'd be something about this, right? Appears in proximity, retains that proximal position, only one at a time. You remove from the display if the user is interacting somewhere, and you need to make a decision about whether to accept or reject data. So how would you do this in Ember, roughly? Probably you would have an outlet in your application template and an action targeting the router. And when you clicked on an element, you would enter into a new route, and that would connect this outlet as part of rendering, and then it would show up in the page. So you'd have a controller and a view. Right? Seems simple, not too terribly weird. And then clicking the back button would also be an action, probably targeting the router, pop you back to your parent state. And then you make a decision about what to do with data as you're exiting that state. How can we handle clicks elsewhere in these other places? In the old world, we'd probably do something like when you click an element, part of its callback is to register a new click event on the body that passes the new thing that just got shown, and when you click, you hide the thing again, right? Very spaghetti. But if we have composable primitives, we can actually do quite a bit better. Right? So if we had a dismiss view, the template of our popover could actually use that. And that just lives at a layer over the entire window. And you put the modal at a z-index 1 slightly higher than the dismiss view. And now the dismiss view's behavior, which you can reuse everywhere, is whenever a user interacts with me, go from my current route to my, my immediate parent route. So we do OK on some of this stuff. These, pretty good. These, not so much yet. We don't have a great way of figuring out exactly when height is being changed in our applications. So overall, B-, not too bad. My suggestion is you punt and you make the little disclosed triangle, just sort of do that, rather than trying to get visual centering, and you're in a decent place. OK, modals. Not many people think of modals and popovers as being the same UI, but they're basically identical. The only difference is modals are not proximal to the user interaction. They're usually full screen. And typically, they can also get triggered as a result of asynchronous data loading, not just user interaction. So if we were to think of the requirements for this, it appears visually centered, can appear and disappear in response to user or data interaction. There's only one at a time. If you remove it from display, if the user is interacting outside of it, and then you have to do some of the accepting and rejecting of data like before. So a pretty similar solution, an outlet, probably an action, and we can reuse our dismiss view. Even though it wasn't specifically coded for modals, it was coded for popovers to start. It's actually the sort of primitive behavior of dismissal is totally a thing that we can reuse. The user interacts with this element, we have another action. They interact over here, our dismiss view takes over from that, jumps us back to our parent route, and part of the routing mechanism is to determine when I exit this route, and if I have unsaved changes, what do I do? So pretty good. We can basically get all of these covered except for centering on a vertical axis. And that's just a limitation of the browser. So A-. OK, next one. Keep building up. A photo carousel. This is me dressed as a police officer in Jackson Prison. So given the number of custom, thank you everyone. Given the number of custom elements in this display, it's really unlikely you're going to find this as a reusable component, right? To find this like as a drop-in thing you can use is pretty much not going to happen. But with sensible UI primitives, we're like 90% of the way there, because a photo carousel is basically just a modal with pagination. So think about how cool that is. Once you've learned how to build modal behavior, you can build a photo carousel by just figuring out how to do pagination. Pretty easy. So a very simple pagination is to control all your photos with an array controller, have a current photo property, and then previous and next actions will change the value of that. And because we have data binding, you know that your template's always going to update to match what the current photo is. There's some additional pagination stuff that we need to handle, like how do you handle rapid successive clicks of the pagination elements? Do you cycle back and forth like the music player example? So pretty good, but because of the pagination stuff not being built into Ember just yet, I'd say B. All right, the date picker, which is the one I get asked about pretty much every time. A date picker is basically a popover. It is also basically a carousel. Can you guess why? Yeah, I mean you're just paginating through months, right? This is not a unique pattern, and yet typically when you see these elements reused on the web, a date picker and a photo carousel are not part of the same code base. So months, you just have to create months. And since the underlying data of this array isn't being fetched, we can paginate through it without having to worry about asynchronous requests. It's basically acting kind of like a sparse array. All we're lacking is a good general purpose, not related to Ember, library that can generate calendars as data structures. And once you have that, you can pretty easily build a date picker that meets exactly the sort of date picking needs that you need. In the past, calendar generation in the browser has been this mixed use, right? Like it always comes hand in hand with a visual display of what the calendar has to look like. And so that primitive library of creating calendars as data just doesn't exist, or if there are, I haven't run across any. And that's a bummer. So this, as you can imagine, would probably be 2 elements, a text field with a data binding to the current controller, and a calendar with that same data binding. And then we know, because of bindings, that when the date changes or the date selection changes, the 2 elements are going to be kept in sync. So that's pretty good. I'd say B+, but I don't remember why, because I was preparing this last night. No, it's because we don't have great pagination support on arrays just yet. And we would need an external library for doing dates as data structures. But that's not specific to Ember. Like, that's a microlib that microlib people should be writing, and just no one has done it yet. So that shouldn't reflect poorly on Ember. Can we share? I think, yes, we should. And can we share high-level components? Like, could I give you my date picker fully formed? Absolutely. Like, that level of reuse, if my date picker is exactly what you need, makes total engineering sense and business sense. There's no reason to remake that. The problem is, or the challenge is, we need to make those part of reusable elements so that if you decide the particular way I'm paginating doesn't match your flow control, you can go look at the primitives I use to compose my date picker, use most of them, and replace the flow control with your flow control. So basically, if you hit that 20% customization mark, you shouldn't have to throw the whole thing away. You should be able to reuse as much as possible of what I got going on. So I went through it fast, and that is the end.